Hello students, I'm Mr. Leung. So in this video, we are going to talk about the Chapter 9 assignment, and in this part we shall talk about the MC question first, and then later on we shall talk about the long question in the second part. So for question 1 to 3 is the same experiment, and this experiment we are going to study the effect of magnesium deficiency on growth of the young seedlings. So before we enter the question, I would like to talk about the setup first, have a brief introduction of the setup, and every part I would like to point out is specific or special for the design of the experiment. So the first one is about the air in. That means we need to pump some air into the solution. So air is pumped to the culture medium or the culture solution in the conical flask. So what's the point I need to mention this part? Because we need to recall the importance of gas, especially oxygen for the root. So actually all the cells or for the whole plant, it needs oxygen for respiration, right? But why do we need to pump air, fresh air? Okay, technically, of course, the fresh air contains oxygen for the root, because the root can carry out respiration to release energy to absorb minerals by active transport. So you can recall that active transport is a energy required process. So that's why if we input some air into the water, so into the culture medium or into the solution X in this experiment, so we can ensure that the root, it must be able to absorb the minerals. So for the second one is about we use young seedling for the experiment, and it's a very common practice to design an experiment. Once the experiment is used to study any factor affecting the growth. For example, in Chapter 5, if we would like to investigate any importance or any effect of calcium for the growth of the mouse, something like this. So that's why we shall use some young mouse, okay, some little mouse, but not the old mouse. Why? So we shall talk about this special design in the question, okay? And for the third one is talking about the aluminum foil covering the whole conical flask. So the concept is that we use the aluminum foil to block light from entering the conical flask. But you may ask, no, Mr. Leung, the root, it cannot perform photosynthesis, right? So why do we need to cover the conical flask? It's pointless, it's meaningless. But we actually, what we are going to do to cover the conical flask by using the aluminum foil is to prevent the photosynthesis carried out by the algae in the conical flask. Algae is an microorganism, okay, which can also perform photosynthesis. So that's why if there is some algae in the solution X, okay, just some accidental contamination, some algae, okay, they appear in the solution X, and once we really give them light for photosynthesis, so the algae will grow, and when they are growing, they will also compete for the minerals with the young seedlings. So you can imagine that, what if there are really some algae in the culture solution, in the solution X, and we do not cover the conical flask by using the aluminum foil and just let them grow? So somehow the algae will grow in the conical flask, and they will compete the minerals with the young seedling. So finally, the young seedling will not grow healthily, because the minerals, okay, it can absorb will be less than before, because the algae competes with the young seedling. And then the fourth one is talking about the solution X. Solution X, what is it? It's the solution containing all the essential minerals for the plant growth except magnesium. So it's easy to understand that, because we are studying the effect of magnesium deficiency on the growth of the young seedling. So that's why we need to remove the magnesium to provide a magnesium deficiency environment for the young seedling to grow, right? So that's why in this part I would like to recall the concept of independent variables in the experiment design. IV is the factor you change, and this factor is also the one you are investigating. You are investigating the effect of magnesium deficiency on the growth, right, of the plant. So that's why in this experiment, IV is the presence or absence of the magnesium ion provided for the young seedling. And this setup, you can see that we do not provide magnesium for the young seedling. So that is our IV. So for this part, okay, I hope you understand the brief idea of the experiment first. For question 1, it's just what I mentioned. Young seedlings should be used for the experiment. What is the reason behind? So one by one, A, B, C, D. So for the option A, the root can be put in the setup easily. So that means if we do not use the young seedlings, the root will be just so complicated, so messy, and then we cannot put it in the clinical fast. Actually, it's just a practical problem. Okay, if we really do not use the young seedlings, we use a bigger plant, it cannot be put in the clinical fast easily. Yes, it may be true, but what if you use a whole pot, a bigger pot? So that's why you can even put the whole plant in the pot and then add some fertilizer except magnesium. So it can also be the experiment, right? So that's why it's not the reason, okay, we choose young seedling. And then for B and C are also wrong. Both of these two statements, technically they are true themselves. The root grow very quickly, yes. They increase in height quickly, yes, because they are young seedlings, just like for the teenagers, for you guys, okay, you are growing rapidly. Now remember, in chapter 5 we talk about why the teenagers, why the babies, they need a lot of protein, because they are growing rapidly, right? Okay, so that's why for the young seedlings or young mouse, young baby, okay, so they grow quickly. That's the truth. But we need to consider, okay, it's not only the truth. We need to consider why we use it. Why should it be used? So that's why actually the advantage of using young seedlings is to obtain the results faster, because they grow faster. So and then we can observe it, okay? But B and C, why they are still wrong? Because the root growth and the change of the height, okay, is not that comprehensive to understand the growth condition. So if we pick up B, okay, as the answer, we use young seedling because I think that the root can grow quickly, so I choose it. So someone may challenge you, why you only pick up the root growth as the only one factor, only one criteria to determine that the growth direction condition? And the same case, if you only choose option C or increase in height, someone may also challenge you, why you only consider the change of height? So what about the number of leaves? So what about the size of leaves? So what about the color of the leaves? So they are also the growth condition of the young seedling, right? So that's why for B and C, okay, they are not comprehensive enough. So that's why they are also wrong. And then for option D, of course, is correct. So why they have little stored minerals, okay, is the reason, okay, for us to pick up young seedlings. So the roots of the young seedlings have a little stored mineral. It's just like the case for all young organisms, young mouse, young baby, something like this. So for example, we want to know that what is the importance of calcium for the mouse to grow. So that's why do we use the young mouse? Because they have little calcium storage. So imagine that the young mouse, they grow rapidly. Agree? And then they do not have much calcium storage. Agree? And then what if the young mouse, they do not obtain sufficient amount of calcium? So what will happen? You may see that the young mouse or the bones will not grow healthily as the normal case. So that's why in this part, the same idea. If the young seedling cannot absorb enough minerals, especially the magnesium ion in this experiment from the solution X, so it will develop the deficiency symptoms so easily. Because what if, imagine that if the root, the plant, we do not use young seedling, we use a old plant, maybe a big tree, something like this. They have the minerals storage already. So what if we do not supply sufficient amount of magnesium to the plant? They still have some reserve, some storage for themselves until the magnesium stored in the plant are all used up. And then the plant will look for, where is the magnesium? I don't have any more. So that's why they will develop deficiency symptoms at that particular moment. It's just so late. So when we are using young seedlings, so we can observe the results quickly. So that's the secret behind why we choose the young seedlings. And then for question 2, the control setup is needed for this experiment. So the control setup should be the same as the experiment setup, except that in the control setup, blah 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 blah, A, B, C, D. So before we talk about the answer, I would like to mention IV, DV, CV again first, okay? Just like a revision for chapter 1. So I would like to talk about CV first. Control variable, it means that the factors are kept constant in both setup, not maybe both, because in this part, in this question, we know that there are 2 setups, okay? But in other or in other experiment, there may be more than 2 setup, okay? So that's why control setup are kept constant in all setup, no matter for the experimental setup or the control setup, to make sure that the investigation is a fair test. So that's why in this both setup, the size of the young seedling, the size of the conical fast, the volume of solution X we use, and the same air pumped into the solution X, they should be the same. And of course, there are some environmental factors as well. For example, the temperature should be the same. The light intensity, supplied to the plants, the young seedlings, they should also be the same. And the humidity, they should also be the same, something like this. So that's why for CV, actually in an experiment, there can be a lot of the CV to make sure that it's fair enough. Understood? So and then for DV is talking about what you are observing or what you are measuring. So in this part, we are going to investigate the effect of magnesium deficiency on the growth of the young seedling. So what are you measuring? You are measuring the growth condition. For example, what I say, number of leaves, size of leaves, color of the leaves, or maybe the height, or maybe the length of the root, something like this. Okay, the growth condition, that's something you observe. And this factor, DV, it depends on what you do to the plant. Okay, so in the experimental setup, we provide solution X containing all essential minerals except magnesium. So in the control setup, what does it mean? The secret thing is that for the control setup, it should be identical to the experimental setup, not environmental, experimental setup. CV, DV, they are the same, right? Except the factor under investigation is absent. So the control setup, we should provide the solution X to the plant with magnesium inside as well. So that means we really provide all minerals for the young seedlings. So that's why we can make a comparison, right? So we go through A, B, C first. So for A, B, C, why they are wrong? For the first part, seedlings are not used. So that means you even cannot measure the DV, right? There is no young seedling, so what for? What do I need to measure? How can I measure the number of leaves? How can I measure the size of leaves? Nothing I can measure. So A is wrong. And then B, solution X is replaced with distilled water. So imagine that. So for the plant, in this setup, I provide it solution X containing all minerals except magnesium. So you can imagine that it cannot grow healthily already, right? So for the control setup, we expect something different. But now, if we really use distilled water to replace the solution X, that means one setup solution X without magnesium, and the other setup is that without anything. Okay, so only with the distilled water. That means no any minerals for this plant. So of course it cannot grow healthily as well. So it's meaningless. And then for C, solution X is replaced with distilled water with magnesium added. So in this one, it seems correct. We put back the magnesium ion, but we remove all the other minerals. You can see that distilled water with magnesium added, it doesn't make sense as well. Of course, we give the magnesium to the plant. Yes, I agree. But you remove all other minerals. So how can the young seedling grow healthily? It will not. So for A, B, C, understood. And then for D, solution X is replaced with the solution containing all essential minerals for plant growth. It's just the case in our table. For the experimental setup, we use the solution X containing all minerals except magnesium. So in the control setup, that means we need to put back the magnesium for the young seedling, and also with all the other minerals. That means it's a very complete, very perfect solution for the plants to grow. So that's why we can compare that with magnesium. Oh, what will it grow? And without magnesium, also what will it grow? And if I can tell you that, with magnesium and with all other minerals, it can grow happily and healthily. And without magnesium, even we put all minerals, but without magnesium, the plant cannot grow healthily. So we can know that the secret should be due to the magnesium ions presence or absence or not. So that's question 2. And then for question 3, it's very easy lah, because you can just refer to the book and then you will know the answer. The seedlings show a yellowing of yellow leaves after 1 week. It is because magnesium is essential for A, B, C, D. Okay, so you just find the answer from the textbook. Okay, it's a very, very easy question. But one thing I would like to mention is that in this question, of course, you need to recall the main function of the common mineral salt. But what I would like to mention is about these 3 parts. Okay, lack of a particular minerals, the main functions of the minerals, and also the deficiency symptoms. Okay, so for these 3 parts, so you can imagine that the question will not ask you so directly. They will ask you indirectly. How? I demonstrate once for you. So for example, I can ask you, I can find that a certain minerals, okay, its function is to doing something. And if the plants lack this type of minerals, so it will develop something deficiency symptoms. So and then I ask you, based on this information, so can you tell me which which minerals, okay, does the plant lack of? So you need to tell me, it lacks magnesium, or it lacks nitrate, something like this. Or if I tell you that, I can tell you, okay, the plant, it lacks magnesium already, lack of the particular mineral. It lacks magnesium. And then I tell you, the deficiency symptom will be like this, yellowing leaves. So, and then I ask you, what is the main function of the magnesium? Just like this question, right? And for the third one is that if I tell you, the main function of a certain minerals is something, and then I tell you if this plant lacks this particular type of minerals, so what will be the deficiency symptoms? So you can also be able to tell me. So that's why for this free unit, okay, actually I can just cover one part and then ask you the other. Okay, so the concept of question 3. So, and then for question 5 is a very common graph to talk about the gas exchange of a plant and the atmosphere. That's why you can recall the basic concept first before we analyze such graph. So we need to know that the exchange of the carbon dioxide of the plant when there is no light, 0 unit of light intensity. So at this moment we can find that there are 2 units of net release of carbon dioxide to the atmosphere. Simply, okay, you understand that because without light, so the plant cannot perform photosynthesis, but only respiration. So you can see that the plant will produce 2 units of carbon dioxide when it's undergoing respiration. Okay, so and then we take a look at the question. So for the option 1, at what 1 unit of light intensity, only respiration occur. So for option 1, you can refer to the graph. In light intensity, unit 1, and then we draw down and then draw to the y-axis, we can see that the net release of carbon dioxide is 1 unit. So that means there is 1 less unit, okay, than before, because without light there should be 2 units of carbon dioxide let released, but now only 1 unit. So what does it mean? It means that the plant carries out photosynthesis and uptake the carbon dioxide produced by the respiration. So you can see that, okay, the simple concept is that once we give light to the plant, so somehow it starts to undergo the photosynthesis, right? But maybe the rate is slow, but actually it can perform photosynthesis at that particular moment, right? So that's why for option 1, it's talking about only respiration occurs. It's not true. So that's why option 1 is wrong. And then for the second one, at 2 units of the light intensity, no net photosynthesis occurs. So in this chapter, you always see the word net. Okay, it has the special meaning, right? So you can see that at 2 units light intensity. So actually, it's the compensation point. And in the compensation point, the rate of photosynthesis is same as the rate of respiration. So that's why there is really no net photosynthesis occur, because the rate of photosynthesis is just the same as the rate of respiration. It's not faster, it's not lower, okay, than the rate of respiration. Okay, so that's why the plant, it is carrying out photosynthesis. Yes, it's correct, but just no net photosynthesis. And then for option 3, at 7 units of light intensity, the rate of photosynthesis is higher than the rate of respiration. So you can see that at 7 units of light intensity, so we can draw a line and then to see that there should be 2.4 units of net uptake of carbon dioxide from the atmosphere. So actually, what does it mean? It means that the photosynthesis is faster than the respiration, right? Because once the photosynthesis is faster, that means it needs more extra carbon dioxide than before. So even the plant, it can provide 2 units of carbon dioxide by respiration, to itself. But the plant still need extra carbon dioxide from the atmosphere. So that's why there is net uptake of carbon dioxide. So you can see that at the 7 units of light intensity. So how much carbon dioxide does the plant need? Actually, it should be 2.4 plus 2 units. 2 units provided by itself, and then 2.4 units uptake from the atmosphere. 2 plus 2.4. That means 2 add 2.4, 4.4 units of carbon dioxide will be required for the respiration. So you can see that, okay? So the answer must be option C, right? 2 and 3. So that's the MC question. So you can see the second part of the video for the long questions. See